pains.
Hi, everyone. Sorry for us being a couple minutes late. These live events always have some technical issues. That's part of the deal. But we're really happy to have you here today. Really excited to start this series of free webinars, and really excited as well to have Marielle along with us to accompany you in this journey and to start your first steps in the data ecosystem, the data vocabulary, understanding these various concepts and topics that'll for sure boost your knowledge of this field and understanding of the different challenges. Now, just really quickly before we start, I just want to point out and introduce Data Scientist a little bit. Data Scientist, so we are a training institute specializing in the field of data, as you might expect. And as such, we've designed courses around the themes of analytics, of data science, data engineering, DevOps, through a very innovative concept which mixes some platform, professors, virtual environments, everything combined in a either part-time or full-time course that'll be sure to get you to your next level. So if you're ever excited or interested in going a step further than this introductory class, then for sure don't hesitate to visit our website and contact us for more information. For here, this is the main topic is Marielle's fantastic webinar and series of webinar to kick things off, starting with some SQL. And I want to leave it off to Marielle to start things there. Obviously, if you have any questions or anything like that, don't hesitate to ask a question in either the question or the chat, and we'll be sure to kick things off from there. And in any case, I want to thank you once more for taking the time for joining this great webinar, and we're really excited to have you along the journey.
Great. So should we kick things off?
Perfect. Let's go.
Yeah, let's start. Cool. Hi, everybody. Thank you so much for joining us on a Friday lunch hour. My name is Marielle, and I will be your host for today. So let me just quickly share my screen. Let's see. Hopefully I'm sharing the right one. Okay, so welcome to a session on SQL Essentials. So I like to start off by telling the audience what you should expect to learn by the end of this hour and a half. So first, you will learn exactly why learning SQL is a must if you want a successful career in data. And then we will go over how to work with data from a relational database. And then finally, you will be familiar by the end of this session, you will be familiar with all the essential SQL commands to get you started on your data analyst journey. Great. So as mentioned, my name is Marielle Dado. I am currently working as a freelance data analytics engineer. And what that means is that I help companies basically build up their analytics platform, their business intelligence platform. So I am currently based in Berlin, Germany. So hi to everybody who's also based in Deutschland. And well, hi to everybody who's based anywhere and joining us today. But yes, I have been based in Germany for the last 10 years. And I have a PhD in a field called applied cognitive sciences. And you can think of applied cognitive sciences as the theoretical underpinnings of AI. So feel free to connect with me on LinkedIn if you have a LinkedIn account. I don't really post content so much, but it's just nice to get to know other people who are interested in data. And I'm always happy to answer questions about data, about SQL, about Python, or any of the things that I work on. Also in psychology as well, since that's what I've studied. Okay, just kind of want to have a look at who's here. Hello, everybody. Thanks for all the shout outs. Okay, I think we're at a good number. And anyway, looking at the numbers makes me feel a little nervous, so maybe I'll just ignore that. But thank you, everybody who's here. Okay. So Theo mentioned that there are a couple of free courses that I'm running over the course of this summer. So you're at the very first session. Congratulations. And there will be 6 more after this. So the first 2 will be about SQL or SQL. The next 2 will be about Python. And then on the 5th session, we'll be talking about the differences between pandas, which is a Python package, and SQL, because both of these languages are very popular tools for data analysis. And it'll be helpful to learn a little bit more about when one tool is best used over the other. And then in September, early September, we'll go over some basics of machine learning using Python. And then at the very last session, we'll learn a little bit about Power BI. So I hope you can join us every Friday, or almost every Friday, at 12 over the course of this summer. Great. So we're going to dive into the content now. So why should you learn SQL? I'm curious to know if any of you already have any pre-experience or pre-knowledge about SQL. Maybe you can give me a thumbs up, or maybe you can type in the chat how much experience you have in SQL. So, and while you do that, I'm going to talk about some of the reasons why you should be learning this language. So SQL is, I guess you could call it a programming language. Arguably, it's a programming language, but in any case, it's a computer language, a very popular one used to retrieve data from relational databases. And relational databases are tools that that are used to store what you call structured or tabular data. So you might have, I'm sure you're familiar with what tabular data is. So if you've ever worked with an Excel sheet, then you've worked with tabular data or with structured data. And if you aren't currently working in the data field, chances are most of the data that you will work with in the future are structured data. And yes, like I said, these are like Excel files or spreadsheets or anything that has rows and columns. And again, tabular data is often stored in relational databases. You might have heard of terms such as MySQL, Postgres, BigQuery, or Snowflake. These are all examples of relational databases. And so it makes sense that if you're going to work with a lot of structured data or a lot of tabular data, and most of these are stored in databases, that you learn the most popular programming language for actually retrieving this data, right? And in fact, SQL has been around since the 70s. So that's a really, really long time in tech terms, if you think about it. It's not just a fad that's going to go away anytime soon. It's a very helpful computer language that is here to stay. So I bet SQL is older than a lot of us working with SQL right now. So these are, at least to me, the main reasons why you need to learn SQL. If you have any other ideas, maybe you can write in the chat why you decided to join us today. But these are the main reasons why you should learn SQL, in my opinion. And if you need a little bit more convincing, here is a survey. Here are the results of a survey that was run by Stack Overflow. So Stack Overflow is a very popular website. You could consider it a social media website, I guess, or a forum for programmers, where programmers get together and ask questions about their work, about their code, which is to say that there's a really, really large programming community in Stack Overflow to the tune of like hundreds of thousands. And Stack Overflow did a survey recently as May of this year, about like different like behaviors, tools, and preferences that programmers have and aspiring programmers have in their work. And I found this result especially interesting. So in short, SQL is used more often on the job than Python. And yet fewer people are actually learning SQL. So as you can see here in this graph, the professional developers who responded to this survey, so around like 70,000 people responded to this, they said that the top 4 most popular programming languages that they use are JavaScript, HTML and CSS, SQL, which is what we're learning today, and then Python. But if you look at the respondents who are just learning how to code, around like 5,000 of them, the most popular programming languages that aspiring programmers learn nowadays are HTML, JavaScript, Python, and then SQL. And notice the gap between people learning Python and then people learning SQL. That's quite a bit of a jump. That's only like 35% of all respondents. So, as a data professional, I find this result rather striking, because that means that, there are a lot of Python classes out there and a lot of interest in Python. But maybe that's not the only programming language that aspiring data analysts, data scientists should be learning. And in fact, it probably should be SQL first. And that's why when I structured this program, this summer of learning, I decided to start with the SQL courses first. So I hope you all agree that it is a good idea to show up today. And let's get started. So, well, actually, let me have a look at the chat. Well, Kareem, I think DataScientest also has some modules on SQL. And it looks like a lot of our audience members today don't have experience in SQL. So I think it's a good idea to turn up today. Great. So working with data in a database. So not a fan of just like lecture type classes when it comes to programming. So let's start by running our first query for today. So how do you retrieve data from a database using SQL? What you see here on the screen is like the most basic structure for a SQL query. So the command that you want to start with is called select, which is pretty obvious. You use it to select data. And from is usually the command that you use to indicate which table you want to retrieve the data from. So I actually have a nifty data set here that is about apartment prices in Germany, which I will explain a little bit more in a minute. And we are going to try to retrieve all of the data from this table. So let's run our first SQL query, select asterisk or star from apartment prices. It's apartment prices and DE. And then limit is a command that you want to use to limit the number of rows in your result, just because, there might be a lot of rows and we just want to see a little sample of that right now. And there we have it. That is our first query for the day. Let me just drag that up there. There we go. Now we have the first 10 rows from the table called apartment prices DE. So we're going to go over this data in the course of the session, and actually during the course of the entire summer program. But I just wanted to demonstrate that this is the basic structure of a SQL query. Select from. And select is often what we use to indicate which columns in the table we want, but we'll go over all of that later. Okay, so again, we're gonna go over a data set that is about apartment rental offers in Germany. And I know many of our audience members today are from Germany, and that's why I decided to go with a data set that is relevant to the people who live here. If you're familiar with Kaggle, which is a popular website for retrieving interesting data sets to play around with, this data set is available on Kaggle. And I will actually drop the link in the chat, just if you're curious to see what that looks like. So this is actually a data set that a friend of mine retrieved about 3 years ago from a website in Germany called ImmoScout24. Those of you who have ever looked for an apartment in Germany knows ImmoScout. So it's a very popular platform for finding apartments in Germany. So yeah, I know people are laughing. It's like, you're going to enjoy looking at this data set with me. The interesting thing about this data set is that it was retrieved. It contains data from 2018 to 2019. And those are the years just before COVID. So it's going to be a very interesting data set to explore. So anyway, this is what we're going to be looking at. But for those of you who are not in Germany, this is what a typical kind of rental apartment listing looks like in Germany. And it's probably similar to any kind of apartment listing in your country or the country where you live. You'll basically have some kind of heading, the address, an indication of how much the rent is per month. And there are like other specific details here that are kind of distinct to how German great our internet is over here. I think, we can pick up where I left off. Sorry again. I'm going to start sharing my screen. Okay. I think this was the last slide that you saw. Okay. So I was just talking about how apartment listings are often displayed in like German apartment portals. And so this is just a snippet of what that might look like. It's not too important right now what the details are, but just so that you know that in this data set, my friend had scraped all of these kind of tiny important details into a tabular form. So, okay, before we start with any of the code, let's go over some important terms first. So a relational database is a collection of tables that have some defined relationship with each other. I can give you a sneak peek of all the other tables in the database we're going to work with today. So we have the apartment prices DE table, which will contain data from the apartment listings of ImmoScout. And then we'll have also 3 different region tables, because as you might have guessed, apartments, they have to have some kind of location data. And the way that it was developed in the data set here is that there are 3 different like regions for every listing. And so there are like 3 different tables here for that. And then we also have a table for coordinates for districts in Berlin. So a database, again, is a collection of tables that have some kind of relationship with each other. And you might also hear the term entity when talking about databases. So entity is just a thing or an object or a concept that a table represents in a database. So let's look at our database again. So apartment prices is a table in our database, and the entity that it represents are apartment prices. Or actually, maybe more accurately, it represents apartment listings, right? So the region 1 table is a table that represents the entity of region 1, level 1 regions in Germany. So if you encounter databases in the future, you might see a table named users. And yeah, a users table then would represent the entity of users. So kind of simple. It's sometimes as simple as that. It might be a little complicated than that, but those are the basics. And so next, okay, let's look at a snapshot of the table and go over some important terms. So this is a column, which you might be aware of. So Scout ID is a column, but sometimes you might hear in like textbooks or in kind of tutorials, this is often also referred to as an attribute or a field. I'll try to stick to the term columns and rows in this lecture. So a row is obviously this thing over here, this horizontal list of data, but it's also sometimes referred to as a record. Again, I'll try to keep terms consistent so as not to confuse people. There are some column descriptions for the data, for the table apartment prices that we will look over today. These were from the Kaggle page that I sent over a while ago. But sometimes in like the real world, you won't have column descriptions for the data. Be quite unstable today, and we're just going to live with that. And I'm just going to like get up and go back into it just like that. Okay, so column descriptions, if you're lucky, you will get them from whoever is giving you data, but in the real world, sometimes these descriptions are not available. But at least we have it available for our course. And this is a popular visualization of how tables often are related to each other in a database. So it's called an entity relationship diagram. And so you can see here that apartment prices, our apartment prices table and the different region tables. And these arrows indicate exactly how we might be able to join these tables together into one table. And we'll go over joins in this lecture in a little while. And so finally, into our code. All right. So as mentioned, to retrieve data from one table, just one table, you want to use the command select from. So select is where you, which is the query that we showed that I showed you a little earlier. And limit is how you tell the database to only show a limited number of records. And so if you want to look at unique values in a column, then you need to use, then you need to use the command distinct with the select statement. So let's do a demonstration of that. So here is our earlier here is our earlier SQL query. And this is how you would want to retrieve all of the records in your table, or all of the rows in your table. Select star from apartment prices. And let me just run that command. And what that will do is that it will retrieve literally all of the table. So it will retrieve all of the columns and all of the rows as well. So I just want to show you that in this table, we have over 200,000 rows. So it's a pretty substantially large table. Okay, so let's try to retrieve the first 5 listings of the table, which you already kind of saw me do. Well, so and you do select star from apartment prices and limit it to 5. So maybe in the chat, you can tell me how you can retrieve the first 100 listings in the table. Wonderful. So that would be this, and then limit 100. Exactly. Okay. So what if we don't want all of the columns in our result? So instead of using the star, we then just write the name of the column that we want to retrieve. So it says here in the comment, retrieve the listing ID and the total rent price of the first 5 listings. So to get the listing ID, it's called Scout ID in this table. So we just type the name of the column that we want after the select statement. So select Scout ID, and then we'll try to find the column that has the total rent price. And it's called total rent over here. So we just type total rent from our table, and then limit to 5. And this is how you retrieve just a small portion of your data set. So again, select and then the columns that you want to retrieve, and then limit it to the number of records that you're interested in. Okay. So let's try another one. So it says here, retrieve the listing ID, total rent price, base rent, service charge, and heating costs of the first 5 listings. So I actually have these SQL queries already prepared so that we can just follow along. So select Scout ID, total rent. Just kind of want to complete this so that I don't forget. We also have a column called heating costs. So we'll see that in a minute. And then service charge. And we said we want to limit it to the first 5 listings, right? Type it like this. And so what are the possible apartment types in Germany? So again, if we want to find unique values in a column, we use the distinct command. So distinct here, and then I will add a column name next to it. And there's a column in our table called type of flat. Let's see what kind of types of apartments we have here in Germany. So we have apartment. We have ground floor apartment. We have a roof story, which is I don't know if this exists in other countries, but in German it would be called a Dachgeschoss, I believe. A raised ground floor apartment, a maisonette, a penthouse, a half basement, terrace apartment, and a loft. So these are the types of flats that we have here in our data set. Okay. So maybe for the audience, if you feel like joining like trying out of some of these SQL queries, or like kind of trying to figure out how to retrieve this kind of data. Let's say we have a column called condition, which indicates all the different conditions of an apartment. How would you find all of just the unique values of this column? So I would put the distinct command here. We can have a look at the different distinct conditions of an apartment. So an apartment in our data set could be refurbished or well kept, fully renovated, or in mint condition. Some of them could have been modernized because there are a couple of pre-war apartments here in Germany, and they need to be kind of, fitted with more modern technology. Some of them are in need of renovation or might be even ripe for demolition. So, and then, okay. So much for that. Okay. So in order to sort our results, because sometimes we need a lot of results and we kind of want to arrange it in some kind of organized way, we use the order by command after the from command. So let's look again at our query up here of what the possible apartment types are. Let's just copy that. Just kind of move it down here where our notes are. Okay. So what are the different apartment types in alphabetical order? We'll just put that query that we ran earlier and then add the order by command, order by type of flat. Well, let's run this query first. So this is our original result, right? It's not arranged in alphabetical order. And now if we use the order by command, it will be organized in alphabetical order. So now you can see that apartment is, well, the null value is on top, and then the apartment and ground floor, et cetera, et cetera. So let's try that with the condition column. Copy and paste that. Change this condition, and then condition, and run. Okay. So now we'll have an easier time actually looking at the results, right? So first time use after refurbishment, fully renovated, et cetera, et cetera. Okay. Now, maybe I haven't mentioned yet is that you can actually run the distinct command on multiple columns. So let's have a look at how that's done to answer the question. What are the different combination of apartment types and apartment conditions in alphabetical order? So we can do that by writing select distinct type of flat condition from apartment prices. And then let's order it by the type of flat. Let's have a look at the result there. We have a lot of null values, but you can see here that an apartment in our listings table can be refurbished, it can be well kept. And we also have ground floor apartments that are, in need of renovation and are from first time use. Let's see what else we have here. So basically, you can see all possible combinations of type of flat and condition by running the distinct command. And you can organize that by alphabetical order as well, so that you can have an easier time sorting through the data. Now, I can actually even order by the results using two different columns. So by just indicating the the columns that I want to order the results by. So what the database will do is it will order by the results first using type of flat, and then by condition later. So now we'll have apartment. The apartment results then will be sorted in alphabetical order, and then the conditions will be sorted out in alphabetical order. And now we have a pretty organized result. Okay. But what if we want the results in reverse alphabetical order? How do we do that? We can use, well, let's simplify this query first. So let's just go with this query first. So we're looking at the distinct types of apartment types. So right now it's in alphabetical order, and to do a reverse alphabetical order sorting, you add the command DESC, which stands for descending. Exactly, reverse equals true in Python. And now we have the results in reverse alphabetical order. And now to do that with multiple columns, you use descending, or the descending command on all of the columns you want to sort by. And there you have it. You go. We'll see that like the raised ground floor and well kept come first. Sorry, no. I mean the terrace flat comes first in the listing and then well kept in the conditions. Okay. So let's try the order by on some numerical columns first. So the question here is, what are the top 5 listings with the highest total rent? So let's see. Oops. Be careful about typos, by the way. So retrieve this listing ID, which is the scout ID and the total rent. So that means we want just to see, we don't want to see all the columns, we just want to see the scout ID and the total rent. Sorry. From apartment prices. Okay. So if we want to see just the top 5 listings with the highest total rent, we can just use order by total rent. And if we want the highest numerical amount, we have to use descending so that the highest amount comes first and the lowest amounts come after. And then we just want the top 5 listings. Therefore, we'll use the limit command 5. And let's have a look. Okay, let's look at our results. And tell me if you think this makes sense. So total rent is supposed to represent the monthly rental payments that you have to pay. So according to the results, Scout ID, this Scout ID, the rent that one would have to pay to rent this place is about 15 million a month. Does that make sense to anyone? Probably not. And this is not actually a real thing, maybe. I mean, I don't know. What do you think? Do you think there are apartments in Germany that go up to 15 million a month in rent? So this is another thing that we have to think about when we analyze data. Like we take for granted that data might be like perfect or clean, but if it especially comes from the internet, data can be really, really messy. So sometimes you will get values like this that might not even make much sense, right? So it's important to really have a critical eye and have a critical mind when it comes to analyzing data. Always think to yourself, does this data make sense? Could there have been an error? Could there have been a problem with data collection, etc.? Okay. So yeah. Okay, so I think this comment is a bit redundant. And so let's go to inline calculations next. Okay, so with SQL, we can actually perform operations between columns in a table, which means that you can add columns together, subtract columns together, divide columns together, or multiply columns together. So in the query that you see here, we are going to be adding together base rent and service charge in order to retrieve just the sum of just to see the sum of these two amounts. So if you're in Germany, base rent here refers to the Kaltmiete, which is the rent that you pay just for the apartment space. And service charge translates to Nebenkosten, which includes things like water, and I believe heating is something else, but it includes, for example, maintenance services in the apartment. So let's see how that works in our database. So let's have. So in order to save time, I might just copy and paste some of the queries I've already prepared. So what is the sum of the base rent and the service charge? So you'll have the column here for base rent, and you simply just add the plus sign with the other column that you want to add, which is service charge. And then this command here, which is as, will give a name, a column name to the result of your operation. So we want to call it sum of the base rent and the services. So let's run that. And there you have it. So we have base rent plus service charge equals sum of the base services. So I just also want to point out that you don't always have to give a name to your columns if you don't feel like it. But I think it doesn't look as nice if you don't give it a name. It'll just basically repeat the operation that you've added here. But so if you want to kind of have a neat result, then just give it a name like this. And there you go. Okay. Now we want to see what percentage of overall rent constitutes the base rent. So what we want to do here is to divide the base rent over the total rent and multiply it by 100 to see the proportion of the base rent over the total rent. So when we run that, we have this result over here. Well, I don't know about you, but I think kind of result like this is a little unwieldy to deal with because of all of the, I guess, the decimal places. And so if you want to kind of make your work a little neater, you can use a function to round off the numbers by to a specific decimal place. And here's how you do it. Let me just copy it over here. And then add the command or the function round. So this is the result before with all of these decimal places and this kind of long, result to just a very neat kind of result, but also a little inaccurate, right? Oops. Oh, sorry. I made a mistake. We want this instead. Basic maths, where you want all of our operations within the same parentheses. There you go. Oh, you should be able to run this properly. There you go. This is the result that I wanted. You have your results rounded up to the first decimal place, and you don't have that long kind of unwieldy result for your numbers. So if any of you are familiar with Python, this is also called a function in SQL. So you can use the round function to round up your numerical results to a specific decimal place. So these operations aren't just for numbers, actually. You can also have operations on text data or on string data. And here's how you would do that in SQL. So the prompt here says combine apartment type and condition in one column. And so first we'll have type of flat, which is the apartment type. And then you can use these symbols to connect this little bit over here, which is like, well, actually, you know what? I'm just gonna like run this command to see, to show you what I mean. So we have these kind of two lines over here to signal the database that we want to combine the results between type of flat and condition. And now we have a combined column of these two results, but it kind of doesn't make sense because it's like there's no space between the two different column values, and it's a little hard to read, I would say. So then I would add another little text here, like a comma, in these two lines as well, so that I'm essentially combining three text values here to make the result a little easier to read. There we go. So now we have a column with a combined apartment type and condition in just one column. Okay, so much for operations. Can continue now. Oh, before we continue, let's just do a quick review of what we've learned so far. So we have the select command that we use to retrieve the columns that we want to see. And then the from command, where we have the table name that we want to get our data from. And then order by, if we want to sort our results using a particular column. So these three, I would say, are pretty much the basic SQL syntax that you might use in your everyday work. I would even go as far as to say the first and the second commands, select from, are you basically have 90% of what you need on a daily basis, unless you are like a SQL developer or an analytics engineer like myself. But as a data analyst, these are the two commands that are the most important. Okay, so there will be cases as well when you're doing your data analysis when you just want a small portion of your data set. You essentially want to filter your data. And to do that, we use the where command. So select star from apartment prices, where balcony equals true, means that we want to find all of the listings in our table where a balcony is available. If you're German, then you know that German people love their balconies. So I think this would be an interesting result to see. So let's run that query, find all apartments with a balcony. If you're living in Germany, let me know if you have a balcony, because I do not. True. I think we need. Let me see if I need. Yep, we do need quote marks. Oh, just for fun. Let's see. And there we go. We have, earlier I said that the entire data set has about 200,000 records or rows. And it looks like that in our table, 165,000 listings in our data are of apartments with balconies. Okay. Now, if we want to find, if we want to even further filter our data using another column, we can do that as well. So in the prompt here, we have find all apartments with a balcony and a lift, and arrange the results so that the priciest listings appear first. So how I would do that would be to use the query that we just had, and then use this operator called AND. And lift is a name of one of the columns that we have here. A lift meaning, an elevator, equals and what this will do is that it will find all listings in our table that have both a balcony and a lift or an elevator. One more thing, we want to order our results so that the most expensive listings appear first. So we order by total rent, descending. Let's see. Oops. Doesn't seem like we have any listings that are in this combination. Just to check, I will run this query again. Okay, here we go. I must have made a mistake. Yeah, let me try this again. But sometimes, depending on your database, it will accept double quotes or single quotes. Well, this seems to have run, but it wouldn't accept it with the other. Anyway, here we go. So our first query over here, there were how many results? There were about 165,000 records. Now we are trying to further filter our data. And then our results are only 50,000 records. So only 50,000 records in our table have, or in our apartment listings table, have both a balcony and a lift. And just for fun, let's look at how much these apartments cost. Okay, so then we still have that ridiculously expensive listing of 15 million a month, which I really think is a mistake. But we still have also really insanely priced apartments here. Let's see, 11,000 euros a month for an apartment with a balcony and a lift. So, I mean, I don't know if this means that the data that we have is faulty since it was extracted from the internet, or there are really, really expensive apartments like this in Germany. In any case, let's move on. I actually have prepared a couple of other queries that we can try, but in order to save time, I'll skip over them for now and then we can go back to them a little later. So I just want to address a question in the chat, which I find interesting. What is the general advantage of SQL over Excel? Thank you for asking that question, Jacqueline. So I believe the maximum number of rows that Excel can handle is 1 million rows. Please correct me if I'm wrong, if someone else has more knowledge on Excel than I do. in this era of big data, you are likely going to be dealing with more than 1 million rows. So one data set that I worked on recently had 5 million rows, which is why that number was top of mind. So you would need to have a table stored in a database in order to hold that much data and to be able to do operations on that data. So that's one reason why SQL makes sense to learn, so that you can manipulate very large tables in a database. And the second reason, I think, advantage over us, Excel would be that, as I said at the start of the session, that most tabular data are stored in databases. And SQL, for the most part, is primarily a computer language for retrieving data from a database. So, you have Excel files, for example, maybe sitting in your hard drive or on your cloud storage, like on Google Drive or whatever. And the only way to retrieve data from these files is to open the files. And there's also no way to combine Excel files together. So if, for example, you have, I don't know, payment data in one Excel file and user data in another, and you want to look at how many users are paying for a service, for example, then you won't have any way to join that table conveniently. And that is one thing that SQL can do really well, which we will go over a little later when we talk about joins. So basically, the advantage is that if you want to retrieve big data from a database and use, then it's good to learn SQL. And if you have a lot of tables or Excel files stored in a database, then it's also really useful to learn SQL. So next, so this is our AND and OR command. Actually, we haven't talked about ORs yet. So let's go over this query again. Let's say that we just want to find all listings that either have a balcony or a lift. So one or the other, and not necessarily both. So let's run this query again. And let's look at the results. So we have 50,000 rows for this result. Now, if we just want all listings that have either a balcony or a lift, we just use OR. These are all of the results. And then we have 170,000 rows instead. So the results that you see here are of apartments that have a balcony or a lift. They may have both, or they may have only one or the other. Okay. So there's another command that we can use as an alternative to the OR operator. So let's say we want to know which apartments in our data set have a decent energy efficiency class. So this is another big topic in Germany, like energy efficiency of buildings. So why is this important? Because if you have an energy efficient building or apartment, that means you won't be paying as much for your electricity bill or your heating bill. And the best energy efficiency classes are A+, B, and maybe even a little bit of C. So, oops, didn't mean to do that. Okay. Find listings where energy efficient class is A, B, or C. So we just learned about the OR operator. And so how we would then do that with the OR operator is to write out energy efficient class equals A, or energy efficient class equals B, or energy efficiency class equals C. And that's one way of doing it. And you can still retrieve all of the data that you need. So we have about 30,000 rows here. But one really convenient way of doing that is to just use the in operator. So basically using in and then putting all of the values you're interested in parentheses. So there we go. And then we'll still end up with the same number of rows and potentially the same subset of data. And it's just a lot more convenient than typing out all of the conditions that you want. Okay. So another way of filtering your data is using conditional statements. So let's say we want to find the listing ID, the year of construction, and the total rent of listings that were built after 1950. So we can do that using this command. Hang on, let me just find there. Oh, it's over to save time. So if you remember your very basic kind of grade school maths, like in order to find, in order to indicate whether a value is greater than or less than, you use these symbols. So it's the same with SQL, and I guess it's the same with Python as well in some occasions. So we have a column in our table called year constructed, which is a series of years when our apartments have been constructed. And to find all of the apartments constructed after a certain date, then you would use this condition called where, a where condition written out as year constructed is greater than 1950. So let's have a look. So we have apartments constructed in 1951 and so forth. We have a lot of data. We have apartments constructed in 2005. We have about 150,000 rows, apartment listings that were constructed after 1950. And now, if we want to simplify our where condition, the way that we simplified the energy efficient class conditions earlier, since let's say we wanted to find all listings that were refurbished between the year 2000 and 2010, we would have to write out a SQL query like this. So where last refurbished was greater than or equal to 2000 and last refurbished was less than or equal to 2010. So let's have a look at those results. And we have about 9,000 listings of apartments that were built from 2000 to 2010. And notice that here that I have the equals sign in my conditional statement because we want to include listings from the year 2000. So if I remove this, and if I remove this, it will just have everything that was essentially built from 2001, I believe. Yep, 2001 until 2009. So basically, it's excluding 2000, the year 2000 and 2010. And that's why this was essential. So, but another command that we can use is the between command. And this is just a lot neater, in my opinion. So it will look a little something like this. So last refurbished between 2000 and 2010. So again, our results here, we have about oops. Be careful of your spaces, by the way, when you're writing out SQL, because sometimes the databases won't like that. So we have about 9,000 rows here, 9,071. And then our results are exactly the same, 9,071 rows. Okay. Okay, but before we continue with the command, I just want to check what people are discussing in the chat. Oh, hey, Akendo, how would you then write out that SQL query then with brackets? If you type out the SQL query that you're thinking about in the chat, I'm happy to run it, and then we can see the results. Okay. So, hang on. So maybe I just want to quickly mention about filtering on null values. So as I mentioned earlier, real world data can be quite messy. And so you will have a lot of null values, like maybe we saw that earlier with our type of flat query. So we'll have values that look like this. So you can use aware condition to filter out these null values in this manner. So we want results that don't have information about total rent. So we will do that with a total rent. Instead of an equal sign, you would use the is command, is null. Oh, sorry, we want the stuff, yeah, without, yeah, okay. So we want to see if there are any listings in our table that don't have information about total rent. Okay, so we have about 40,000 listings in our table that have no information about the total rent. So this is how you would run this command. I suppose it will also work with equals command. Okay, it won't work that way. In some databases, it would. So if you wanted to find the data that do have total rent information, you would write is not null. So then we have about 200, a bit more, over 200,000 rows. So it's a little different if you're trying to find values that don't exist versus values that do exist. If that makes sense. Okay. So let's go over more ways to filter our data. So let's first look at our firing types. So firing type, at least in our data set, let's have a look at what that data is. So we have in our column called firing types, let's order that by ascending order. We have things like bioenergy, coal, district heating, and stuff, and electricity. So this basically is a column that shows what kind of energy sources that we have for specific apartment listings. So you can see that there are a lot of firing types or energy types that have gas. So you have gas and gas in bioenergy, gas in district heating, gas in electricity. But what if we want just the listings that have an energy source of gas? So one way of doing that would be to use what we learned earlier, where we find the result using the where condition, and then the column name equals the value that we're interested in. So that's one way of doing it. But then again, the results, as you see here, will only be of firing types with gas. And so what about all those other like firing types that we saw earlier? And that's where the like command will come in. So, oops. So the like command will essentially find values in your column that are like the value that you specify. So let's try like. Okay, we still have over 100,000 rows. Oops. And okay, we still seem to just have firing types equals gas. So it's essentially the same result as what we saw earlier. But I'll show you a little trick, which is called in SQL the wildcard. You add a parenthesis, a percentage sign before and after the value that you're looking for, which is gas. And let's run that. And what this will essentially do, so this command will find any value that has the word or the letter combination GAS in it. So you'll have natural gas heavy, which is even more than, these are even values that we hadn't seen earlier in the listing. Obviously, it will show gas as well. Oops. But all the other types of firing types as well. So natural gas light, et cetera, et cetera. So here's that's another way of filtering data. Okay. So just doing a quick time check. Okay, so here's like a summary of the syntax that we've learned so far. So again, select columns to return from a specific table, where, and then the condition that we want to filter our data on, and followed by order by, which is the command that we use to sort our results. So you must have maybe picked up that when it comes to SQL, the order of our commands is very important. So you can't have the order by before the where, or you can't have the where by before the from. And so this is something that you have to keep in mind. Okay. Okay. I think I will skip over the case when, because I really want to go over the joins. Because this is, I think, quite an important topic when it comes to SQL. And this is really in line with what we discussed as the advantage of SQL over Excel. So when you have a SQL database, then it gives you the power to join tables together in that database to create another table. So it basically enables you to combine data together. So, okay, give me a second. Just preparing my, okay, cool. Okay, so, well, okay, let's go over the apartment price, this NDT relationship diagram. So what we haven't really discussed in the data set is like the location of these apartment listings, right? So we haven't seen whether a listing was for an apartment in Berlin or in Munich, et cetera, or in like one of the 16 states in Germany. Excuse me. Wait, how many states are there in Germany? So, so we should be able to get that information from the region 1 table or the Regio 1 table. And so how we're going to do that is to do a left join, a left join between apartment prices and the Regio 1 table. So before we do that, a little bit of information about what a left join is. So let's say you have two tables. You have a customer table and then an orders table. So what a left join does, at least in our example here, is that it will combine all the rows from the left table. And left here is defined as the table in your from statement. So the left table here is customers. And it will only get the rows or the records from the right table that have matching values with the column that you specify in the join. So that means that in this case, so we have left join orders. This is the orders table. And you join it on the customer ID. So which means that in the new table, we only have records that the records from both tables that are matching on customer ID. So for example, we have here Sebastian, customer Sebastian with customer ID 1412. And in the orders table, we have the amount of their order, which is 200. And therefore, we'll see that appear here. And then for customer LOD as well, we have her customer ID for 4114. This also appears in the right table. And therefore, we see her order amount here. But what about for Florian and Caroline? We don't see their customer ID at all in the orders table. And therefore, we will see a null amount in the result, if that makes sense. So in the end, we get a new table. And in this new table, we have the same number of rows as the left table. But if on the column that we use for joining, which we call a key, if we don't have their values in the right column, then we won't be able to match any data with them, and therefore it will appear as a null value. Okay, so going back to our data. So find the state. Let's start with just the state. We won't go with the district and city just yet. So find the state of each listing. So to simplify that, I've already prepared the query. And it will look a little something like this. Oops. So we have, from the apartments prices table, we have the Scout ID, which is the listing ID, and then the total rent. Okay, let's just remove these parts as well. And actually we should have a look at this this table first. Oops. So in the region 1 table, we have a list of this 16 states in Germany. And what we're trying to do is we're going to try to find the state of each of these listings in our apartment prices table. So we have Regio 1, left join Regio 1 as R1. So basically, we're just giving our table a nickname so that it's easier to write in our query. On apartment, okay, because we have this this alias as well for our apartment prices table. Regio 1 ID equals Regio R1.Regio 1 ID. So what it does is that it will take all listings in our apartment prices table. It will take the Regio 1 ID of those listings and match it with the Regio 1 IDs in the Regio 1 table. Hopefully that's not too complicated. And let's just try to run this query. And we have that as a result. So in order to maybe get a more substantial query result, what I'll do is I'm going to retrieve all of the columns in our apartment listings table. So notice that, like, if I want a specific column from a table, I will use the alias. So R1 dot and then the column name. Now I want all of the columns in the apartments table. So then I will write it out as apartments dot star select. So I just had noticed. The question in the chat, why do we need to use star in the last example? Maybe I forgot to explain that if you use the star select, or select star, you will be retrieving all of the columns in that table. So now let's run this query. Okay, and now we have our listing table, including now information about the state where this listing is from. But the thing is, so I've explained in the slides that it will only, that the left join will only match two tables if we can find a match between the columns that you specify in the left join. The thing is, with our region 1 table, it's a pretty small and organized table. And every listing in our apartment prices table actually has a Regio 1 ID. So we would definitely find a match between the listings and these values. But what if, say, we want to find the coordinates of all listings in Berlin? So not all of these apartments are found in Berlin. And let's say we want to know what the, let's see, where is that? What the geographical coordinates of Berlin, of the Berlin listings are. If you've ever needed geographical coordinates, I don't know, if you're navigating, I don't know, in the woods or something like that, then you would be familiar with the geographical coordinates. Then you would use an inner join. So an inner join, for that first. So inner joins and left joins are the most common kinds of joins that you would do for your data analysis. So this is different in the left join, in that only rows from the left table and the right table will be matched. So for example, in our customers table, we have, again, Sebastian, and we found his customer ID in the orders table. In LOD, we also found her customer ID in the orders table. But for Florian and Caroline, we couldn't find their customer ID in the orders table at all. Therefore, when you do an inner join, their results, their records will not appear in the results. So let's go back to our database. Let's see. Okay. Hang on. Okay. I'll have that. Kind of, this is a bit of a long query, so I will kind of type it out slowly. Okay. So we want the wait, let's go back to region 1. Let's look for the ID for Berlin. So Berlin has the Regio 1 ID of Regio 1_1. So what we're going to do first is to find all of the listings that are actually from Berlin. Regio 1 ID equals Regio 1_1. But these are all of our Berlin listings. And notice that I'm putting the inner join just before the where clause. Inner join on the Berlin coordinates table. And we're going to do something a little kind of special here, I guess. We're going to join the tables on the postcode. So every listing will have a postcode, and we can use the postcode as a key to combine tables. So inner join Berlin coordinates as B. Let's just kind of give that a shorter name, B, and then we'll add the geo point 2D column on apartments and geo PLZ or Postleitzahl if you speak German, and the Postleitzahl. Oh, sorry, I picked the wrong ID. My bad. I'll comment that out. There. And there now we have all of the listings for Berlin, including their geographical coordinates. And so just so that we can have a better look at the data, I will try to retrieve all of the columns for the apartment listings table. There we go. So we have about 10,000 listings that are from Berlin only in our listings table. And remember that our original listings table has about 200,000 listings. And so inner join actually excludes every other listing that doesn't have a postcode in Berlin, just because we are unable to find their postcodes in the Berlin coordinates table, and therefore we cannot match them, and therefore they are excluded from the results. And so we are actually we've gone about like 5 minutes over time, and so I would think it's time for us to wrap up here. It looks like I've prepared more content than we had time for, but at least you can tune in next week so that we can go over some of the other essential commands in the context of an exploratory data analysis. But before I let you go, I thought I'd share some books that you might want to read if you're trying to learn SQL for data analysis. So one book that I really like is SQL for Data Scientists. If you're especially interested in a data science career, I think this book summarizes some of the most important uses for SQL in the context of data science. So SQL has many other uses that I wasn't able to discuss in this session, and some of them are not even related to data analysis at all. But this book is a really good summary of why data scientists need to learn SQL. And it will exclude all the other kind of points about SQL that you don't need to learn in the context of data science. So I highly recommend this book. And then another great book is SQL for Data Analysis. So if you're maybe not as interested in a data science career, but you want to be you want to know enough SQL to pick up business intelligence skills, then I would recommend the SQL for Data Analysis book. And it will discover, and these two books have a lot of great content that thankfully I will also be covering next week and in the rest of the classes that I have planned for you in this summer. So thank you so much again for joining me. I know we went over time, and it means a lot to me that you spend all this time with me. Again, please connect with me on LinkedIn if you feel like it. And have a good weekend and hope to see you back next week. Bye, everybody.